So now we're going to be working with rectangular prisms, and rectangular prisms are things that you've been working with your entire life when you're playing with blocks and things like that. They're three-dimensional objects that are made up of rectangles, and you see them all around here. You probably have one of these at home, a refrigerator. That's a rectangular prism. It's made up of rectangles on all sides. If you look around, you can see a couple of filing cabinets here. Those are rectangular prisms. You can see there's a Kleenex box. That's a rectangular prism because all sides are rectangles. This building has some bricks in it. Same thing. This kite, give you an idea of what it looks like. And again, we've got the aquarium downstairs. Now, if you look around, you can probably see a few more rectangular prisms. Like your book is almost a rectangular prism. And that Rubik's Cube that's over on the side there, that's close to a rectangular prism too. It actually is one. It's a special type of rectangular prism, and you probably have used this language before. It's called a cube. That means when it's a square on all sides. And remember, squares are just special rectangles. So what we were talking about in terms of three dimensions. Three dimensions, generally, the way that it's described is three dimensions. They describe things like a refrigerator, and trust me, I know this because I just bought a washing machine. Dishwashing machine, because mine went ahead and broke. They describe the amount of space that it takes to fit into your house. And so if you don't have that amount of space and you buy the wrong size refrigerator, then you're just going to be stuck. So if you look here, this refrigerator, it says has a certain dimensions, are 3 by 5 by 2. So the way that they write it, 3 by 5 by 2. 3 feet by 5 feet by 2 feet. And what those dimensions are is that there's generally what they're called length, width, and height. We have length and width and height. Those are the different measures, front to back, and again, in this case here, I'll just show you what I mean in terms of length and width and height here. What we have here is we have a height of 5 feet, a length of 3 feet, and a width of 2 feet. So that's the length and width and height. And you yourself, you take up a certain amount of length and width and height, you're just not in a rectangular prism. So the space that you take up is a lot harder to calculate than it is for something that is made up entirely of rectangles. So the volume of a rectangular prism, that's the amount of three-dimensional space that an object occupies. When you go ahead and you fill up a bathtub, there's a volume of water that fills up into that bathtub. If you go over it, then it overflows. Again, your milk carton has a gallon in it. That's a type of volume. And when you fill up your gas tank, that's a type of volume, again, gallons. And there's also things like liters and milliliters. In science class, you probably have worked with things where they have milliliters and things like that. That's the amount of stuff, the amount of three-dimensional space that is taken up with something. So to calculate it, and I'm just going to read what this says here, volume is the amount of space a three-dimensional object occupies. And frequently it's said 3D, 3 dimensions. You can think of the volume of a box as the number of cubes that will completely fill. And we already worked with this with Unifix cubes somewhat. And there's a couple of different ways to solve the problem that's listed here. How many cubes will fit into this box? So this is a description of the box. And if you look at it, there's a couple of different ways to think about it. This is what the box is when it's unfolded. I know it can be a little bit hard to visualize, so I'm going to kind of draw in what the actual pieces are here. So, for example, this side here is going to be this piece here. This side here is actually going to be this tiny piece right here. Then we have this piece here. It's going to be this front piece, and also this piece here. It's going to be that back piece there. And then we have this blue piece here, which we can't see because it's on the bottom, and we can't see it. So that's how I want you to visualize this. If you were to fold up this box, how it would look. And it says here, very important, if you look closely at how Olivia did this, what she did was, she said, well, there's three, it's 3 high, or it's 3, the 3 and then 5. So the 3 length and 5 width. And so when you do that, you end up with 15 on that bottom row. So what she's doing is this. She's taking that bottom row that's this part here, and then she's multiplying it by how many rows there are. And how many rows are there? There's a total of 4 rows. So she knows that there's 15 on the bottom times 4, which is going to be 60. Now Joshua, he did it a little bit differently, but it's the same concept. So let's look at how he did it. So if we look at the example that he did, he went ahead and he said the front of the box, I'm right now reading here, the front of the box is a 4 by 5. So he just went ahead and said, well, the front of the box is a 4 by 5. 4 by 5 is going to be 20. It's going to take up 20 pieces. And then it goes 3 back. So that's going to lead us to 60. And that's going to be your total amount. And you get the same answer either way, as you noticed. So another example here. Martin solved this problem. It says here the bottom of a box is 12 by 5. The box is 8 units high. What is the volume of the box? Well, first off, again, what you got here is you've got 12 by 5 is going to be this measure here, so that's going to be 60. And then, so it would fit 60 cubes in that bottom part. But it's going to be actually 8 units high. So 8 units, so we're just going to multiply that by 8. And we end up with 480. So I want to do a couple more problems just to make sure that this makes sense. So let's say you have a box that's 3 inches long, 4 inches wide, and 2 inches high. How you'd figure that out would be well, you'd figure out that bottom level, which is 3 times 4, which is going to be equal to 12. And then you'd multiply that 12 times 2. And you can actually do this for a rectangular prism by just going ahead and doing 3 times 4 times 2, which is going to actually be 24. But this works mainly for a rectangular prism for volume. Remember, this is just for volume. And the easiest way of doing it is to actually measure that bottom level, or the logical way here. And so if I have a swimming pool and it is 10 feet deep, so that would be the equivalent of 10 feet high. And it's 30 feet wide. And let's say it's, let's make it a really nice size swimming pool. Let's make the swimming pool 50 feet long. So that's length, width, and height. That's just slightly different versions of the same word. So all we're going to do is, well, the length times the width is going to be 30 times 50, which is going to give us 1,500. And then that's the amount of space just in that bottom level rectangle, if it's assumed that it's all the way, it's 10 feet high all the way. So now what we're going to do is we're going to take that 1,500, multiply it by 10, end up with 15,000, which is a lot. That would be a very nice size pool. So that's how you go about doing these problems. And what you're going to be doing next are some problems out of the textbook. So good luck, and I will see you tomorrow.